Hi everyone. Today we're going to study numerical integration. In engineering and science, it is frequently hard or tedious to evaluate the problems of definite integrations. In here, we will study some of the numerical methods to find the numerical value of the definite integration without integrating it actually. As we know, the definite integral, and that is the integral from a to b of the function f of x dx, is equal to the area between the graph of the function f of x, the x-axis, and the vertical lines x equals a and x equals b, as shown in this graph. Extending this idea in the numerical integration by dividing this area to some shapes and collecting the areas of these shapes to get an approximated value of the required integral. On this topic, we will discuss two tools for approximating a definite integral to any degree of accuracy. There are two methods. The first is trapezoidal method, followed by Simpsons method. These tools are used to evaluate definite integrals when the integrand has no simple antiderivative. Moreover, we sometimes only have information about a function by making observations at a certain number of data points and no available formula for the function we are integrating. We shall discuss the two methods on the next videos. Today we're going to study trapezoidal rule. In this method, we divide the area enclosed by f of x, x-axis, and two vertical lines, x equals a and x equals b, into n plus 1 trapezoids, having equal width, that is h. Look at this illustration. On top is the graph of y equals f of x. Below is the x-axis. On the sides are the vertical lines x equals a and x equals b. Look at the x-axis. We have some arbitrary numbers. So we have a, then x sub 1, x sub 2, x sub 3, x sub 4, up to x sub I. Then we have x sub n minus 1. And the last is b. In here, the a is considered to be x sub 0 and b is x sub n. This is now the formula of trapezoidal rule. The definite integral from a to b of the function f of x dx equals h over 2 times the quantity y sub 0 plus y sub n, which means the y values corresponding to the first value and the last value, plus the constant 2 times the sum of the y values of the corresponding x values. In this formula, the h or the equal width is equal to b minus a over n, while the n is the number of equal parts or the number of trapezoids between a and b. Look at this example. Approximate the integral, the definite integral from 0 to 1 of the function x squared plus 2 dx using trapezoidal method with n equals 8. The step 1 is to list the given values. First, we collect the y is equal to the function x squared plus 2. Then, the lower and upper limits respectively. A equals 0 and b equals 1. And the n is given as 8. Step 2, let us calculate the width h. Our formula, b minus a over n. So we substitute like 1 minus 0 all over 8. Simplifying this, we will get the decimal 0.125. Step 3, let us complete the table of values. So we have here two rows for x and y respectively. In here, we're going to write n plus 1 columns. So we have n as 8, so we will write here 9 boxes or columns. In the first box for the x, we will write the value 0, that is the a, and the last box is the number 1, that is the b. In between, we're going to fill the values. In doing so, we're going to take this value 0 added to the value h, and we will get the value here. This value plus the h, that is equal to 0.250. This value plus the h will get 0.375. This value plus the h, it becomes 0.5. This value plus h becomes 0.625 and so on. Now let us get the values for the y. We're going to use this formula. So for the first box, we're going to write this as y sub 0 equals substituting the value of x. This is 0 squared plus 2, and this is equal to 2. Let us write this on the blank. Let us get the value of y on the last box here. So that will be y sub 8. And this is equal to the value of x is 1. So we have 1 squared plus 2. This is equal to 3. And we copy it in here. That is the y sub 8. Now, we're going to fill the remaining values of y using this pattern. So it becomes like this. Now step 4, we're going to use the formula. Then let us substitute the corresponding values. So our h is that 0.125 over 2 times the quantity, this y sub 0 plus y sub n, in this case y sub 8. So we write here 2 plus 3 plus the constant 2. We copy it here, multiplied by the sum of the remaining values of y. Using our calculator, we can simplify this value into 2.3366. This is now the final answer. Today we're going to study trapezoidal rule part 2. Let's begin with absolute error and relative percentage error. We let capital A be the estimated value and capital B equals exact value. For the absolute error, the formula is absolute value of A minus B. For relative percentage error equals absolute value of the fraction, the numerator is A minus B all over A, multiplied by 100%. Let us see this example. Approximate the integral, definite integral from 0 to 2. The function is 1 all over 1 plus x squared, then dx. Using trapezoidal method with 8 sub-intervals. Also, find the exact value, absolute error, and relative percentage error. First, let us solve this problem by trapezoidal rule. The step 1, we're going to list the given values. The function or y equals this 1 over 1 plus x squared. Then we write the limits a and b. The values are 0 and 2 respectively. The n equals 8. Step 2. Calculate the width h. Our formula is b minus a all over n. Substituting the values, we have 2 minus 0 all over 8. We simplified this into 0.25. Now step 3. We're going to complete the table of values. We have here a table with 2 rows. First row for x values, second row for y values. For the columns here, we're going to write n plus 1 number of columns. Our n is 8, so 8 plus 1, we should write here 9 columns. Let us complete the x row. The first blank here is reserved for the value of a, which is 0. The last blank of x is reserved for the b, which is 2. Now let us complete the remaining values. The next blank here is equal to the 0 plus the value of h, which is 0.25. Next value, 0.25 plus the h, which is 0.5. 0.5 plus the h, 0.75. So that pattern will continue up to the last value. Now, for the y values. We regard the first one to be y sub 0, y sub 1, up to y sub 8. Let us now find the values of y. We're going to use this equation. The y equals 1 over 1 plus x squared. Let's begin with finding the y sub 0. Using this formula, we have now y sub 0 equals 1 all over 1 plus 0 squared. This 0 is the value of x in here. Simplifying this, we have now 1, and this value we're going to substitute in here. Let's proceed with finding the y sub 8. Using the same formula, y sub 8 equals 1 all over 1 plus 2 squared. Simplifying this, we have 0.2, and we substitute this value in the blank. We can complete the values of y using this pattern, and these are the values. I put here some examples of solutions. Now, the table is complete. We can now proceed with step 4 using the formula. Here is now the formula for trapezoidal rule. We'll simply substitute the corresponding values and it becomes like this. And from here, we can use our calculator to find the final answer, which is 1.1063. So that is the problem A, solving this integral by trapezoidal rule, and the value is 1.1063. And we consider this to be the estimated value. Now we're going to get the exact value. In here, we're going to use the integration formula. The integral of 1 over 1 plus x squared dx is equal to the inverse tangent of x. And we are going to evaluate this with respect to the limits from 0 to 2. We can now substitute and it becomes the inverse tangent of 2 minus the inverse tangent of 0. We can use our calculator to find the corresponding values. But make sure that calculator must be in radian mode. So the values are 1.1071 minus 0 respectively. And the final answer is 1.1071. We can write the answer in here. Then the absolute error. Our formula is the absolute value of A minus B. The A here is this estimated value. The B is the exact value. Substituting the corresponding values, we have now the absolute value of 1.1063 minus 1.1071. The answer is the absolute value of negative 0.0008. And we simplify this into 0.0008. Now, the relative percentage error and our formula is here. Substituting the corresponding values, we have now this expression, and this expression can be simplified into like this, and further it becomes like this. We take the absolute value of this expression, 0.0007 multiplied by 100%, so the final answer, 0.07%. Today we're going to study Simpsons one-third rule. We know that the definite integral from a to b of f of x dx represents the area bounded by the function y equals f of x. Below is the x-axis. On the sides are the lines x equals a and x equals p. Now, the Simpsons one-third rule estimates the area by this formula. The h here is the width with formula b minus a all over n. And this n here is the number of equal parts between a and b. N must be an even number. Now for the formula, this y sub 0 plus y sub n is the sum of the first and last terms. Then plus the constant 2 multiplied by the addends. This y sub 2 plus y sub 4 plus ... is equal to the sum of even indexed terms. Then plus the constant 4 multiplied by this group. Y sub 1 plus y sub 3 plus and so on means This is the sum of odd indexed terms. This is the example. Use Simpsons one-third rule with n equals 8 to approximate the integral from 2 to 6 of the function 1 all over the square root of the quantity 2x minus 1, then dx. First, let us list the given values. Our function, or the y, equals this 1 over the square root of 2x minus 1. The a and b are the limits of integration with values 2 and 6 respectively. The n is equal to 8. For step 2, we calculate the width h. Our formula is here, b minus a all over n. We substitute the corresponding values. We have now 6 minus 2 all over 8. Simplifying this into decimal, we have now 0.5. Step 3, let us complete the table of values for x and y. For the number of columns here, we write n plus 1. Our n is 8, so 8 plus 1 must be 9. So we have here 9 added columns. For the x row, we have now the first blank reserved for the value, which is a, and that is 2. For the last blank for the x, that is reserved for the value b, that is 6. Now let us complete the values of the remaining boxes. For the next box, we will have this number 2 plus the value h, that will be 2.5. For the next blank, 2.5 plus the h, that will be 3. 3 plus 0.5 becomes 3.5. This 3.5 plus h, we have 4. This pattern will continue up to the last value, which is the number 6. Now for the row for y. We name this starting from y sub 0 up to the last value, that is y sub 8. We will now compute for the values of y using our function here. So let's begin with the y sub 0. We substitute the corresponding value of x. So y sub 0 equals 1 all over the square root of 2 times 2 minus 1. Simplifying this, we have 0.5773. So we copy this value in here. And we can proceed with the last value, the y sub 8. So this becomes y sub 8 equals 1 all over the square root of 2 times 6 minus 1. Simplifying this, we will get the value 0.3015. Then we copy this on the blank. We can fill the values for the y using this pattern, and we have these values here. Now we can go to step 4 using the formula of the Simpsons one-third rule. And this is now the formula. We substitute the corresponding values and it becomes like this. Using our calculator, we can start by adding the groups. So we have this group, the sum will be this one, plus the constant 2. We add the 3 decimals, it becomes like this. Plus the constant 4, we add the 4 addends. We have this number. Then we multiply the constant by the decimals respectively. So we have now this value we copy here, plus this value is the product, plus the product of this expression. And the total of these 3 decimals will be 9.5072. From here, we can multiply this decimal by the 0.5 and divide by 3. So our final answer is 1.5845. I hope you learned something from this video. See you again next time.